This is my data visualization case study part 2, where we will be discussing about question number 6 to 10. So in this case study, we have already discussed about question number 1 to 5, where we discussed very important questions related to mobile sentiment lead, policy mix, topic spikes, and a lot of other questions as well. So which had individual representation for each of the questions. So I hope that answered the previous questions. So now we will be discussing about a couple of other questions which are important as well. So I'll give an overview about our project. So this project demonstrates that social media sentiment, mobility patterns and government policies create predictable feedback loops. So to understand the purpose of the project is very important, right? So our purpose is to understand these relationships and build better early warning systems such that we can reduce the outspread of the future pandemics, and also we can improve the effective crisis management for the future pandemics. So this is the purpose of the project. Now we'll discuss about our data sets. Sets documentation. I've clearly mentioned what the data sets we have used here. So in this in the documentation that I've mentioned, we have used COVID-19 tweet data set, which has around 3,75,000 tweet records, and then we have Google Community Mobility Reports, which also has which is the official report by Google, and then which contains 6 mobility categories across various countries. And then we have the Oxford COVID-19 government response tracker, where we have 400,000 policy records, which contain gold standard for policy tracking, and then it also contains information about stringency and economic support indices. Then also we have the JHU CSSE COVID-19 dataset, which has around 750,000 records, which contain authoritative epidemiological data, and also it contains daily confirmed cases and deaths globally. Now that we have understood the purpose of the project and the dataset we have used, now let us take a look into the research question 6. So here we will be discussing about the case growth versus the topic evolution. So the question would be, during the exponential case growth phases, which LDA topics showed the largest proportional shifts? So here for this to answer this question, we have visualized eventually in the upcoming scroll. So we have used two data sets, which is the JHU CSEC COVID-19 dataset and the COVID-19 tweets dataset. So the approach we have taken to visualize this, first we'll be identifying the exponential case growth phases, and then we'll be analyzing topic prevalence during each of the periods and the baseline periods, and then we will be calculating the proportional shifts in each of the topics. Then we'll be visualizing. So let us take a look into the visualization. So this is the visualization we have made after all the processing and calculations. So here, as you can see in this visualization, there is a bar chart and a box plot. So in the box plot, as you can see, there's a 12.3% decrease in the lockdown related topics during the baseline, and then there's a 5.5% increase in other topics during the exponential growth phase. And then the box plot reveals that distribution pattern by the growth phase, which has a clear evidence of discourse shifts during the health crisis. Now moving into the question number 7, which handles the details about regional discrepancies analysis. So which countries exhibited the largest gaps between peak mobility reductions and peak negative sentiment? So the datasets used to analyze and visualize this question would be the Google Mobility dataset and then the JHU dataset. So the approach we have taken to visualize is that we'll be first identifying the peak mobility reductions by country during the analysis period, and then we will be calculating peak negative sentiment periods for each of the country, and then measuring the temporal and magnitude gaps between these peaks. Then we'll also be ranking the discrepancy size and analyze patterns. So after doing all the processing and the calculations, we'll be visualizing it. So I'll move into the visualization now. So this is a visualization. This is basically a multi-panel timeline comparison, where will be the blue line will be mobility reduction and the red line will be negative sentiment. As you can see here, timeline plots comparing Australia, Brazil and Canada. So the peak mobility and sentiment marked with the vertical lines, that is red and blue. So the time gap analysis reveals that country specific coupling patterns, there are coupling patterns in this, and then there is also quantified discrepancy scores for each of the nation. After understanding the visualization, that we have concluded that there are quantified discrepancy scores for each of the nations. Now the research question 8, sentiment as leading indicator. So how effectively does a downturn in average tweet sentiment forecast a rise in confirmed cases 1 or 2 weeks later? So to answer this question, we have used COVID-19 tweets and then the GHU CSSE COVID-19 dataset. So as I mentioned the question earlier, to solve that and visualize, we have used this approach. That is, by first we'll be identifying the significant downturns in every daily average sentiment, and then the track all the COVID-19 cases. That is between the first week to the second week. That is 7 to 14 days after the sentiment downturns, and then we'll be calculating the predictive accuracy and then lead lag correlations to visualize. After that, we'll be assessing the effectiveness of the sentiment in as an early warning indicator. So after processing and the calculations, we'll be visualizing. I'll move into the visualization now. So as for the visualization, we have used a scatter plot matrix where there are representation for 7-day lead, 10-day lead, and a 14-day lead. So here we have represented through scatter plots which show the sentiment versus the future cases, as the question suggests. So here we can understand that the correlation coefficients are 0.042, minus 0.353, and 0.266 for each of the representation. Here the 10-day lead shows the strongest negative relationship, and also the trend lines demonstrate the predictive capability. So this is it for the question number 8. Number 9, we'll be discussing about the relationship between stringency versus the sentiment resilience. So the question would be, do regions with sustained high containment indices exhibit faster sentiment recovery in social media discourse? So to answer this question, we have used two datasets, that is Oxford COVID-19 dataset and the COVID-19 tweet dataset. So the approach we have taken to answer the question would be to first identifying the regions with sustained high containment indices. That would be very obvious, and then we will be measuring the sentiment recovery patterns which follows the policy implementation, and then we'll be comparing the recovery rates between high versus low stringency regions, and then we'll analyze whether stricter policies leads to faster sentiment adaptation, which leads to answering the question. So now let us take into the look into the visualization. So the visualization is the sentiment recovery pattern, that is high versus low stringency examples, which has a dual panel line plots with recovery metrics. So here, as the legend suggests, the dotted line is for sentiment minimum. The dotted red line would be sentiment minimum, and the empty dotted line would be the initial level, and then the right line would be 3-day average, and the red dotted line would be the daily sentiment. So here we have understood that the time series comparing Canada, that is high, and the New Zealand, which is the low stringency, has a resilience score which is quantified to minus 0.246, which is 0.917. So here it shows the recovery trajectories clearly differentiated, and then also the policy implications for crisis management is also visualized here. Now taking a look into the question number 10, which handles the relationship between economic cushion versus the behavioral fatigue. So to answer the question, which is how does the level of economic support influence the point at which the public behavior, that is the mobility, and sentiment begin to decouple from the government policy stringency. So to answer the question, we have used three different data sets, which is the Oxford dataset, Google Mobility dataset, and the COVID-19 tweet dataset. So to visualize this question by answering it, we have taken this approach. First, we will be identifying the coupling and decoupling points between policies, mobility, and sentiment. Then analyze the role of economic support. Then detect the behavioral fatigue patterns across different economic support levels. Then we will be examining public sentiment and mobility to visualize. So moving on to the visualization, we have this multivariable line plot with coupling matrices. So we have a clear legend mentioned here, that is red line for policy stringency, blue line for mobility compliance, and green line for sentiment. So here, as you can see, we have visualized Canada high economic support and Brazil, which has low economic support. As you can see here, we have also calculated and visualized where the overall coupling for Canada is 0.217, and then the overall coupling for Brazil is 0.509. From this, we can understand that the economic support buffers maintain the behavioral compliance. So that is directly related. So this is what we have understood from the question number 10. Now that we have answered all the 10 research questions along with its respective visualizations, I've also added a detailed methodology documentation where I've clearly mentioned all the technical details which I've used for answering all the 10 research questions. And also all of these details are also uploaded in my GitHub repository, where you can read through the documentation for any further queries. Thank you.